Hello, this is a very quick code walkthrough through the insert file of catena, which is a time series storage engine written in Go. Now, my goal is to make this under 5 minutes, but I've done this a couple of times, and every time I go over 5 minutes. So um, I will try to rush through it just because um, there isn't too much going on, but um, we're only looking at one file, and there's a bunch of stuff that's um, called into other files, and um, for simplicity I'll just stick to this one function, which is insert rows. So the insert rows function is one of the exported methods that you can call when you're using catena. So the user of the package will basically make a new instance of a database or a DB, and to insert data into the database they will call the insert rows function. So one of the only parameter is a slice of rows, and that's defined in the catena.go file. It's a really simple struct that you can look at, but I won't spend too much time on it. So one of the things to note is that there's no restriction on what kind of timestamps that you can include in the rows slice. So you can have rows that overlap. You can have a slice with rows that overlap partitions. So they could you could have 2 points that live on separate partitions, and that's fine. The user of the package has no concept of a partition because all of that's sort of internal logic. Um, so that's why the first thing we need to do is separate these rows into the individual partitions that they belong to, and that's dependent on the partition size. So there's this key that's calculated, and they get reorganized based on key, and then the keys are sorted in ascending order, and then we just go through each one of the keys corresponding to the oldest timestamp to the newest. So um, basically, most of the function here is going through the this loop right here, which is iterating through the keys. So what this basically means is that we're inserting rows one partition at a time, or creating new partitions if necessary. So the first thing that we need to do is get some metadata about the min and max timestamps represented by the rows for that partition. And so just a quick note, pretty sure this is a bug here. That's supposed to be a 0. My personal projects don't really go through code reviews, so things like that slip through. I haven't really noticed this cause problems, but it's not really meant for production use. So once we get some quick metadata, the first thing that we need to do is find a partition. Now, the partitions are organized into a linked list. That's the partition list here, and it's implemented as a lock-free list. One of the reasons for that is that um, the partition list is the most contentious data structure in the entire database because every action acts on a partition, whether you're iterating through points, inserting new rows, or compacting old data. Everything has to go through the partition list. So it makes more sense to, or I think it makes more sense to have a linked list where you can sort of drop things off the end when they're compacted or expired or whatever, and then adding new stuff at the head. So that's why it's a linked list, and making it lock free just makes things a little bit more convenient. So the first thing that happens is we need to find a partition. So I have a label here for that, and I'll get back to that later. So depending on the timestamp ranges and what the current key is, we'll find a partition, and if we find a partition that the current key represents, then we'll go ahead and skip to the valid partition label. And there's also a hold and release method for partition. So val here is a partition. Sorry, it's not that clear. So you can hold on to a partition and release it, and that's sort of like taking a reader lock. There's an exclusive hold and exclusive release that corresponds to a writer lock. But that doesn't really happen here. Now, if we don't find a partition, we'll go through this block here. And there's another mutex here because if a partition doesn't exist and it has to be created, we need to make sure that there's only one Go routine that's attempting to create that partition. So if we have two Go routines that are flowing through this code right here, we need to make sure that only one of them is able to make a new partition, because that also means you have to make a new write-ahead log, and we don't want two Go routines or threads making attempting to make that file. So so we have a condition here that checks to make sure that the rows being inserted aren't too old. I'm pretty sure we can move that up into here, but since the partitions are organized from the newest to the latest, meaning the newest partition would be at the head of the list, we'll basically jump out of the loop anyway. So we have the overhead of taking the lock, but I don't think it's that bad. So once we know we have to make a new partition, we basically go through this block here, and there's a bunch of miscellaneous things to do when creating a new partition, like creating a write-ahead log, stuff like that. I don't really think it's that clean to do it in this function, but I haven't really had time to refactor. And then there's some atomic operations happening here to make sure that if we're on the first partition, then we update the min and max timestamps, and update the partition ID, stuff like that. And here, as I mentioned, we have the find partition label here, and I think this is mainly left over from a previous refactor. I think before I didn't have this this mutex, and I had issues with two threads, coroutines, excuse me, sort of fighting over making the wall and stuff. But I don't know, stuff like this. I'm not really sure if the this block ever gets executed, so it might just be dead code. And this too, I'm not really sure if this ever gets executed, because we're sort of guaranteed to make a partition, I'm pretty sure. Yeah, so we unlock the partition create lock, and then now we're onto the block that is responsible for actually inserting data. So if we find a partition that's read-only, we just release it and then return an error. Otherwise, most of the rest of the code is error-free, except inserting rows into a partition. Now this only fails if the write-ahead log can't be modified, or we can't reliably or durably write data to that log. But otherwise, it's pretty straightforward. You insert points into a partition, release it, and yeah, so I mentioned the writer lock before. Notice that we're not taking an exclusive hold on this. The exclusive holds only happen when you're when the compactor runs. I think that's the only one, because it needs exclusive access, because it's actually deleting that partition and the corresponding files and stuff. So If you're just inserting points, you don't have to take an exclusive lock because there's some other finer grain locks inside. So besides that, we have a couple of loops here to make sure we atomically update the min and max timestamps, and return nil. So that's basically it. If you have any questions, and just ask me on Twitter. Thanks.